All right, let's talk about science class. For decades, the way we've taught science has looked, well, pretty much the same. But what if I told you we've been looking at it all wrong? There's a new vision out there, and it's all about transforming students from just passive observers into actual active investigators.
So, I've got a quick question for you. Take a second, seriously. When I say science class, what's the first thing that pops into your head? Because I'm willing to bet that for a whole lot of us, the memories are kind of similar.
Yeah. Does any of that ring a bell? Memorizing tons of facts, labeling diagrams over and over again in those labs, right? They felt more like following a recipe. Add 2 drops of this, stir for 30 seconds, than any kind of real discovery. It was this world of separate facts where every question had one and only one right answer. Science was basically treated like this giant encyclopedia you just had to memorize.
But then there's this powerful idea, this quote, that just completely flips that whole script. The research is so clear on this. Children are born investigators. They come into this world naturally curious, just driven to figure things out. So maybe the question isn't, how do we get kids interested in science? Maybe the real question is, how do we stop getting in the way of the little scientist that's already inside them?
Well, to answer that exact question, this new vision has emerged. It's called a Framework for K-12 Science Education. And listen, this isn't just some minor update. We're talking about a fundamental, from the ground-up rethinking of what it even means to learn science.
So here's how we're going to break this all down. We'll start with its big idea, this new 3-dimensional plan. Then we'll walk through each of those dimensions, the practices, the concepts, and the ideas. And finally, we'll see how it all comes together for this one huge goal, creating science for all.
Okay, so the absolute heart of this whole framework is something called 3D learning. And yeah, the subtitle here just nails it. It's all about this huge shift away from just knowing about science to actually doing science.
So, what in the world is 3-dimensional learning? Well, think of it like this. Real, deep understanding happens when you weave together 3 things: what scientists do, how scientists think, and what scientists know. It's only when you bring all 3 of those together that the magic really happens and learning feels authentic and, actually sticks.
This chart really spells it out, doesn't it? The way I like to think about it is, it's like learning to cook. The old way was just memorizing recipes. The new way is about understanding the actual techniques of cooking so you can go and create whatever you want. We're moving away from science as the static, dusty book of facts to seeing it for what it truly is, a dynamic, active way of knowing.
All right, let's dive into how this all works, starting with the first dimension, the practices. This is exactly what it sounds like. It's the doing part. This is the active, hands-on work of scientists and engineers.
So these practices are basically the essential skills that scientists use every single day. This means students are now learning to ask really meaningful questions, to build models to explain things, to analyze data and find the patterns. And this one is huge, to actually engage in reasoned arguments based on evidence. They're not just learning what we know anymore, they're learning how we know it in the first place.
Okay, next up is dimension number 2, the cross-cutting concepts. Right, so if the practices were the doing, then these concepts are the thinking. You can think of them as the intellectual toolkit that unites every single field of science.
These 7 concepts here, they're like a set of special lenses a scientist can use to make sense of any problem. It doesn't matter if you're a biologist studying cells or an astronomer studying galaxies, you are always looking for patterns. You're always trying to figure out cause and effect. These concepts create a common language that connects all the different branches of science.
And that brings us to our third and final dimension. And this one is probably the one you remember most from school. The disciplinary core ideas. This is the stuff, right? The actual content and foundational knowledge of science. The framework organizes all this knowledge into these 4 big buckets. But, and this is so crucial, these big ideas are no longer taught as just isolated lists of facts to be memorized. No way. Instead, they become the playground where students get to use the practices and apply the concepts. So you don't just learn about an ecosystem, you build a model of its energy flow, you look for patterns, and you argue from evidence about its stability. See the difference? It's massive. So you take the doing of science, those hands-on practices, and you combine that with the thinking of science, those big picture concepts, and you ground it all in the knowing of science, those essential core ideas. and you weave them all together. And that's the whole ballgame. The real power isn't in any single one of these dimensions by itself, it's in how they're integrated. That's what creates a deep, lasting, and genuinely useful understanding of science.
So why do all this? Why make such a huge shift? What's the end game here? Well, it all boils down to one simple but incredibly powerful phrase: science for all.
And here it is straight from the source. The number one goal is not just to create a bunch of new professional scientists, though that's a great bonus for sure. The main goal is to make sure that every single student can graduate and be a smart, critical consumer of scientific information in their daily life. It's about empowering them to really understand the world and to participate in those big public conversations about things like our climate, our health, and new technology.
Ultimately, what students gain are skills that are just essential for modern life. They learn how to evaluate the claims they see in the news or on social media. They develop a real appreciation for science as this creative, dynamic, human process, not just a boring list of answers. And maybe most importantly, they build a foundation that lets them keep learning long, long after they've left the classroom.
See, this new framework isn't just about changing what students learn. It's about changing who they are as learners. It's about nurturing that curiosity they were born with and empowering them with the real tools of investigation. Which leaves us with a pretty exciting question, doesn't it? What will a generation of true investigators discover?